Hello children, welcome to Right Tuition Classes. We are doing Icse Physics Standard 10. We are doing exercise 3C. We are doing exercise 2C. So I'm so sorry, exercise 2C. Okay. Now, exercise 2C. Okay. We start with the sum. Question number 1. A ball of mass 0.2 kg is thrown vertically upwards. A ball of mass 0.2 kg is thrown vertically upwards with an initial velocity of 20 meters per second. That means you're throwing this ball up. The moment it leaves your hand, just it leaves your hand, the velocity is 20 meters per second. Now imagine as it goes up, the velocity keeps on reducing. Okay, so it will reach one height, where the velocity becomes zero. That height we call it as maximum height. We call it as maximum height. Are you getting me, children? So velocity is zero. That means it loses all its kinetic energy and only it has potential energy. So naturally, potential energy is maximum at that place. Okay. So what am I going to do? See, a mass is equal to 0.2 kg. Okay. Initial velocity is equal to 20 meters per second. Okay. The moment it was through, now they wanted to calculate, only these two are given. Calculate the maximum potential energy. Maximum potential energy. Okay. Potential energy it gains, okay, maximum potential energy. So I told you one thing, children. I'm going to rub it up here, something. Like you throw it with your hand. So maximum speed is 20 meters per second. जैसे ऊपर जा रहा है उसका velocity कम होते जाता है. At maximum एक जगह आएगा जहां velocity zero हो जाएगा. That means वो ऊपर जा ही नहीं सकता. That is a maximum height. तो वो point पर उसका maximum potential energy रहेगा. लेकिन खाली ये दो दिया है. थोड़ी मैं पोटेंशियल एनर्जी का फॉर्मूला mgh. अरे जी का वैल्यू भी नहीं दिया है क्वेश्चन में. जब क्वेश्चन में जी का वैल्यू नहीं दिया है, यू शुड नॉट टेक anything of your choice. Again, you cannot say, come on, let us take it as 10, let us take it as 9.8. So that itself is a hint. You should understand. See, we are doing exercise 2C based on law of conservation of energy. So to calculate this maximum potential energy, what am I going to do is, children, I'll just simply write the kinetic energy of the ball at the instant it is thrown, but it is equal to the maximum all. It had only kinetic energy. When it left your hand with the speed of 20 meters per second, it had only kinetic energy. It didn't have potential energy that time. So it goes up, and now at maximum height, it has only potential energy. Actually, this kinetic energy just got converted into potential energy. So that is law of conservation of energy. So see what I do, according to law of conservation of energy, law of conservation of energy, okay, I'll say energy or kinetic energy at the instant ball was thrown is equal to maximum, or just say potential energy at maximum height is equal to potential energy at maximum height. That means whatever, please have a look here, kinetic energy it had has got converted to potential energy. I think kinetic energy I can say always, therefore half mu square. I taken the mass, the initial velocity is equal to potential energy at maximum height. At maximum height. So what will happen, children? I think half into 0.2 into 20 into 20. This 2 is 0.1. 0.1 multiplied by 20 is 2. 2 into 20 is 40 joules. Okay, how much you get? 40 joules is the answer. So remember, is equal to potential energy on potential energy at maximum height. Therefore, 40 joules equal maximum height. So can I see the answer? The maximum potential energy equal maximum potential energy is equal to 40 joules, children. So this is question number 2, Sika, question number 1. Okay, children. I go to the next sum. Question number 2. A stone of mass 500 grams is thrown vertically upwards with the initial velocity of 15 meters per second. What is the mass of the stone? 500 grams. It is initially thrown with the velocity of, get it? With a velocity of 15 meters per second. 15 meters per second. This is the initial velocity. Okay? In a movement, the stone is leaving your hand. That time, okay, the velocity is 15 meters per second. Now, as it goes up, the velocity keeps on reducing. And when this velocity becomes zero, that time the stone has reached maximum height. So, they want to calculate the potential energy at the greatest height. So, solution now, according to this A part, according to law of conservation of energy, energy at potential energy at maximum height is equal to kinetic energy of the stone at the instant it is thrown. That means this potential energy at maximum height is equal to half mu square is equal to half into m is 500 upon 1000 into 15 into 50. So it is 225 upon 4. 4 5s are 24, 6 are 24. 56.25 joules. The potential energy at maximum height is 56.25 joules. The kinetic energy on reaches the ground. Now again, B part. Kinetic energy of the ball on reaching ground is equal to potential energy at top. 56.25 joules. Then the total energy at its halfway point, the total energy equal to 5 joules by law of conservation of energy. Got it? Okay, children. If this question number 2 gets over,